Now we'll start with UDP. Generally, whenever an application program anything wants to have connectionless service and a speedy service where errors doesn't matter, then generally they go for user datagram protocol. We will see how it operates. Let's begin with the header of the user datagram protocol. That means we know that every layer should have header, right? That control information. Now your UDP will have this header. Exactly, see, only 8 bytes. Did you remember network layer headers? That means IP header. So IP header was having 20 to 60 bytes. Huge header, right? Because it was doing lot of functionality. But here your user datagram protocol is going to have very less functionality. That's why very small size of header. So only 8 bytes. First of all, we'll look into this header. After that, we'll see how this header is connected to our remaining story. See, out of 8 bytes, this we can divide it into 4 parts, 2 bytes each. First 2 bytes is source port. We know that every application will have every process will have port number, right? So we are going to write source port number here and destination port number here. These two are essential for communication. Now total length of the data which we are going to send, that is total length field, that will have 2 bytes, that means 16 bits. So source port is 16 bits, destination port 16 bits. We know already, right? Port numbers are 16-bit numbers. Now we'll see total length. With total length, since it is 16-bit number, so we can generate 0 to 65,535 patterns. So 0, if I write, it will be indicating that your packet size 0 bytes, okay? But it is impossible. Why? First of all, you see what it represents. Total length means your header plus data. So what is your header size? 8 bytes. Assume that, let's say this is your UDP header which we are talking about. It is having 8 bytes. Then if your data size 0, still 8 plus 0, 8. So total length of this entire data is 8, correct? So that's why remember one thing, this total length counts complete data, that means data plus header, remember it. So that's why we can't write total length field as 0, okay? The minimum value, if your data is 0, 0 plus 8, 8, we can write 8. That means total length can take minimum 8 and maximum, so it is not actually maximum 65,535. What is the reason? We will see. So for that you should understand this small issue. What is that is, where are you going to keep this UDP packet? Let's call it as UDP packet from now onwards. Whenever I say UDP packet, that will have header plus, this is UDP header, this is your UDP data. This entire thing let's call UDP packet. This UDP packet you are going to keep in IP packet, correct? So this is your datagram. So in the datagram you have IP header, okay? So IP header 20 to 60 bytes. Then this part, if I embed it here, it will be UDP header followed by data. Now my question is, did you remember in IP header also we have a total data length field, correct? And it was also having 16 bits. With that you can have at most 65,535 bytes data, that is maximum, remember it. So maximum data size IP header allows is only 65,535, because just recall that IP headers packets control information. In that we have seen that total length IP allows only 65,535, of course including its header. So now depends on IP's header. Example, let's say for time being we assume that IP header is 20. Simply your IP says that remaining size is only 65,535 minus 20. That is what IP's rule, right? In that way it is going to support the packets. Now 65,535 minus 20 is 65,515. This is the maximum data IP can carry. On that now come to our UDP. In UDP we have header and data, correct? This entire thing is IP data. So already UDP header is 8 bytes. Then 8 plus dash is 65,515. So 65,507, right? So now you have a limitation, you see. Though there are 16 bits for total length, don't think that we can keep 65,535 bytes of data here. Though it is allowed technically, if you keep 65,535 bytes, then this entire thing, this plus your data. Now recall, see, this entire thing is, you are saying that 65,535, then plus if I add IP header, you are going to get 65,555, but you cannot have datagram of size 65,555. I am doing reverse engineering. I am asking same question from reverse side. Why an IP datagram cannot have 65,555 size? The reason, IP protocol is having total length field. It is having only 16 bits. For that maximum, datagram size, datagram means header plus data. So maximum IP datagram size is 65,535, but you are getting 65,555. We can't have it. Understand? So that's why we have to reduce the size of the data here. So that, remember only one thing. If IP header takes 60 in the worst case, then you will get only chance to have 65,535 minus 60, because maximum size IP datagram will be only 65,535. In that itself you have to adjust your data. Okay, so finally this UDP datagram, I can say size should be 65,535 minus 60. So here this total length is going to represent your UDP datagram size, that will be 65,535 minus 60 at most in the worst case. That is what I would like to tell. Now we will see this checksum, last 2 bytes. So checksum is optional. It is up to you whether you want to have checksum or not. Sometimes applications want fast transmission. They don't want to checksums everything. Checksum takes some time, correct? Example, let's say you send a packet. Receiver has to do the checksum, correct? You will calculate checksum. Receiver will cross check the checksum. It will take lot of time. Some applications really doesn't want it. Okay. So for that we use optional checksum. It is not compulsory. Sir, but how receiver will know? That means I am talking about how receiver's UDP will know that this checksum is optional. Like how it will know that we have to skip it. Simple. For that what we do is we write all zeros. Whenever this checksum is all zeros, that means what? There is no checksum. That means we are not calculating. Understand? Now we'll see some more details about this checksum. Okay. But this is the rough idea about your user datagram header. Okay. UDP header. So very simple. Just 8 bytes. If you ignore the checksum part, almost nothing is there. Source port is compulsory. Destination port is compulsory. Apart from that, you have extra only header size. Your complete datagram size. You don't have more than that. Sir, why this one, sir? Why we have to know the length of the user datagram? Why we require it? We will see. Now we'll focus on total length. Why this field is required, I will tell you. For that, go to application layer first. So application layer is going to have process, correct? So let's take one process P1. It is having some port number something around 50, just for simple discussion. So it is well known port number. Generally we don't have. Let's use something X so that there will not be any issues. So the process P1, and it is having port number X, that wants to communicate with another process in another device. So that is process 2. Okay, its port number is, let's say, Y. So now application is going to give, let's say, IP address will be IP1 here. This is IP2. First of all, application layer is going to find out the IP address and port number. Okay. So finally, that is the responsibility of application layer to find out which process, which port number, for which port number we are going to communicate. Second one, what is the corresponding IP address? Let's say IP1. Okay, this is IP2 and port number X. So now this application layer is going to give this to transport layer. Now our transport layer is having a protocol UDP, correct? Now we are talking about such UDP. So that simply UDP is going to do this one. UDP is going to create header first of all, correct? So assume that, let's say, data is D. Data will be taken from the application layer and details will be taken only. For simplicity, assume that 2 essential things will be taken. Mr. Application layer, otherwise process P1, what is your port number? X, fine. And what is the destination port number through which for which you want to communicate? Y. Okay, fine. And my dear application or process, please give the data D. Okay, now what is the data length? So this application is going to give data length also something 75 or anything 75 bytes. Did you remember? We will have source port number, destination port number, that is UDP header, and we are going to have total length of the total length. Okay, data size 75, then our header length is 8 bytes, right? Then it will become 83. This is total length. Now anything else? The next thing is we will be having data, of course, here data. Apart from that, optional checksum. Okay, assume that let's say we are not calculating checksum. Then at that time we will be keeping all zeros. I will tell you the clear idea about how to calculate checksum and other details. At this moment, let's say some default, we are not calculating checksum, but something randomly fill. Now this is going to be data which is otherwise information created by your UDP. X, Y, 83, everything is taken from process only. But we added what? Checksum, if and all if we want, that's it, not more than that. So this will be given to network layer. So did you remember? Your network layer is going to treat this entire thing as its data, and it is going to create a datagram. So in the datagram, it is going to add IP header, correct? IP header. On that IP header, it wants IP address of the destination. Now IP network layer or this IP protocol is going to ask Mr. UDP, my dear UDP, to whom I have to send the data? I want IP address. So already this UDP is having the IP address which it will take from application layer. So finally here we write IP address. I hope you remember IP header. In that IP header we have a field called source IP, destination IP. In the place of destination IP we write IP1. So now this entire thing is nothing but this one. Let's call this as something, data. So that data will be added here and this will be sent. So we should not worry about this communication, because end of the day this entire thing will come to network layer, correct? So this network layer sends to this network layer. So there what we are going to do is that network layer is going to decapsulate this header part, then only data part will be given to UDP. So finally UDP is going to get X, Y, 83 and optional checksum whatever it is if there is no error, followed by D. Now what that UDP is going to do is it will cancel all these things. So data will be given to whom? What is the destination port number? Y. So that will be given to Y. So my dear Y, please take D. In that way communication takes place. So with the help of network layer, finally we moved this packet from here to here. Further, network layer adds header, remember it. Then here a destination network layer will remove it. Again it will give the old data back. That's why I can say without thinking about network layer also we can answer it. We can understand this one. So UDP is going to create this kind of packet. It will be received by your destination. Then after the data will be appropriately sent. So question number, some of the essential things we'll try to answer. How this UDP will know that we have to give to Y? Because we have the details, right? That's why using that UDP is going to do that. First of all, sir, how did we get this one to exactly our destination? Because application is going to give us IP address and we are going to give, that means UDP is going to give that IP address to network layer. That's why definitely this, I can say packet will come to definitely the destination. At destination there will be UDP process or entity that is going to process X, Y, everything. Okay, now data part will be given to your process in that way. And source, sometimes your destination wants to know who is that source. Okay, then source port number will be given. Sometimes we give source IP address also, not a problem. Okay, in that way communication takes place. So this is the UDP process. We have to discuss how this checksum will be calculated. Understand? Before that we'll see what are the services your UDP is going to offer. So your UDP offers process to process communication, connectionless service, flow control, error control, checksum. Generally any transport layer has to offer, right? We'll see various details like, so process to process communication will be offered as usual. That means if any process wants to communicate with another process, yes, it is possible through UDP, just we have seen. Next, connectionless service. So every packet will be treated as independent entity and they will be delivered. Whether in the transit, if they are lost or not, doesn't bother your UDP. It will not take care of that. Finally, some of the packets will reach the destination process. But if there is any, I can say if there is any mistake at network layer, if some of the packets are lost, then they are lost. Okay, and we have checksum also. Using the checksum, sometimes we do error calculation. If there is an error in the packet which is received by UDP, you know what UDP does? Simply it will discard, but it won't inform the sender. That is a danger with UDP. But if you want such kind of service, you can go for UDP. That's it. Okay. Now finally, connectionless service. These are the features of connectionless service. Discarding the packets without informing to user. Second one, if some of the packets are lost, not taking care of them, everything is the property of connectionless service. Now flow control. So we don't do any flow control. That means there is a sender, there is a receiver. If sender wants to overwhelm receiver, that means sender sends thousands of packets to receiver. I am talking about UDP versus UDP. If sender UDP sends thousands of packets to receiver UDP, then this there is no flow control. Simply we take whatever we want. Example, out of them you have only buffer for 500. Take 500, discard remaining 500, and whatever you hold, only that you give to your application. In that way, so your UDP is so irresponsible. Okay, no flow control, no error control. Of course, we do error control, only little bit error control. What is that? We do checksum. Through that we do some error control. Of course, it's not about error control. So we don't ask. Generally, error control is about, are we asking your sender to send it back? No, we are not asking. That's why. So there is very minimal error control. But with only we do checksum. What is checksum calculation? We'll see how this checksum calculation will be done. We will see. Now we'll see UDP checksum. How UDP is going to calculate checksum. So it's a standard actually. So blindly remember the various fields, whatever they are going to use. That's it. Okay, that is more than sufficient. How this UDP is going to do the checksum is, it is going to take two things. One is header of the UDP and some part of the IP header. So that is also known as IP pseudo header. We will see that IP pseudo header. Source address, destination address, and some 8 bits portion in the IP header where there might be some fields, but we don't take that field values. We fill all the zeros in that 8 bits and we take it, and some 8-bit portion of IP which we take, which is nothing but protocol part, and 16-bit UDP length. That means we are going to take UDP I can say length. So you know what is UDP length, right? What is UDP? UDP is nothing but it is a packet at transport layer. So you will have UDP header plus data, right? This entire thing is called UDP. So this length will be taken here, that is 16-bit. Of course, we know that already. So finally, let me revise. 32-bit IP address, source address and destination address, some portion of IP header with filling all zeros, exactly 8 bits. Then 8-bit protocol, since it is like say this is, we are taking from IP, right? So if it is IP version 4, that protocol will be 0100 in that way. Okay, whatever it is. Then 16-bit binary pattern which represents UDP length. Already just I explained you. That means entire datagram length. Okay, UDP datagram. That means UDP packet length, header plus data. Now after that, this will be your UDP part. You know what UDP contains, right? So especially UDP header, source port, destination port, and UDP datagram length, we know that. Already we have discussed it. So you see one thing. Here we are taking UDP datagram length. Here also we are taking UDP datagram length, because IP header also contains total length field. Please recall. From the total length field, rather than that, we are taking UDP length here. Generally, IP header contains total length, that contains IP header plus data. But here, rather than that, what we are taking is 16-bit UDP length. Blindly remember, it is UDP size, this one. Here also UDP datagram length we are taking. So I can say you are taking UDP datagram length, yes, 2 times. Okay, that is the way this process will be done. Don't worry about the reasons for it, because it is standard. So according to standard, we have to do it. Then checksum. So here checksum will be initially 0. Once you calculate checksum of all these, already I told you how to calculate checksum. Then these bits will be filled. Okay. Now data. So data is nothing but your UDP data. So in this one UDP header data, this will be data. Okay. So I can say that finally, what are the fields you are going to take is source address, destination address, and some 8 zeros and 8-bit protocol value which is from IP header, and from this one UDP data length, sorry, UDP packet length, just remember, not data, UDP length, that means header plus data. Next, source port, destination port, then again UDP length, that means entire data, UDP packet length. Then this checksum initially will be zeros. Okay. Then data, we know what is the data, application layer gives that entire thing, and you already explained checksum how we calculate. We take all your this binary pattern and we divide it into 16-bit units. Okay. Then 4 hexadecimal digits, and we take all the 4 hexadecimal digits and we add them. You get, and after that if you get end around carry, we add that to again least significant digit, then you form one 4-digit, especially hexadecimal, right, 4-digit pattern, that is going to be checksum, and we are going to do ones complement for that. Once you do ones complement here, especially for if you do calculation with hexadecimal and we do 15's complement, doesn't matter, blindly remember, already I explained you how to calculate checksum for given patterns. So please refer in IP protocol I taught you. So that same procedure will be used, and whatever the answer you get, we write here. Okay. So this is the way checksum will be calculated. Now, sometimes sir, you said it is optional checksum, right? That means what? Sometimes, so if your application doesn't want to have checksum because application don't want to waste time, then we go for optional checksum. That means we don't calculate, so that quickly we can send the data. That's it. That is the reason. So at that time we are going to fill all zeros. So we don't do this calculation. Okay. So finally we are going to send the packet like this. I am talking about our UDP packet. So this is your UDP header. Okay. This is your UDP data. And one more thing, don't think that we are sending this entire thing to destination. You are absolutely wrong. Only for checksum calculation, I am just showing what are the fields we use. Okay. But actually what we are going to send, I will tell you. Let's see the story. This is your application finally. Application is having a data called D1. Let's call D1. This is application data. So now your UDP, let's say application layer contacts UDP. Sir, why application layer wants to contact UDP? I mean, we don't know. But your application can contact TCP also. Though it is having two options like UDP, TCP, it is preferring, let's say, UDP. That's why we are discussing about UDP protocol. If this application layer prefers TCP, then we have to discuss about TCP. That's why this is now our discussion is about UDP. Then I am assuming that your application layer calls UDP. Now it will give all the information. What is that? So recall UDP header, source port address, destination port address, IP addresses, everything will be submitted. Now here we are going to have that 4 fields, 8-byte fields. Recall everyone, what is UDP header? Source port, destination port, checksum and data length, correct? Now apart from these 4, data D1, this is the exact packet which will be sent. Okay, that will be, of course, after that network layer adds its own header. I don't want to talk about that, but at transport layer, this is the data, I can say. Okay, this will be taken by your IP as a payload. Now IP is like this. This is IP followed by this entire thing. Let's call something transport layer data, right? T1. So IP T1 will be sent, but of course in the next level again one more header, data link layer header will be added. Doesn't matter for us. We would like to focus here now. Understand? Now see, what if you don't want to calculate checksum? Then simply write zeros. But there is another case. We calculated checksum and if we got 0, then that is possible, right? So let's recall that thing. So there is a danger that there will be a confusion. So there are 2 cases. One is we don't want to calculate checksum. Okay. So no checksum. Then we will be writing all zeros. Second one, we are calculating checksum, but we got all zeros. Then what are you going to do? Yes, it is possible to have all zeros because the process in the process. So what if you get, because did you remember, we are going to take all the 16-bit patterns and we are going to add. But when you add everything, there is a chance that you might get all ones. Since you are doing ones complement, okay, then that one will become, every one will become 0. Then you might get finally checksum as zeros. Then how that UDP at receiver will understand it is because of case number 1 or case number 2. That's why you remember, if you want to, when you calculate checksum really, and if all bits are zeros, then simply make all ones. That's it. Okay. Now this case will become all ones. Now see, at receiver side, UDP is doing like this. It will check the checksum. It will first of all see the checksum. All zeros. It will understand that checksum is not calculated. So it will not evaluate the checksum unnecessary. Correct. Second thing, if checksum value is all ones, then it will understand that, oh, checksum has been calculated. The original checksum is actually all zeros. Then that's why they made all ones. It will do one more time, bitwise complementation. So it will get again zeros back. So this is the real checksum. Okay. Now while calculating the checksum, so your receiver will do again, the procedure of checksum, and it will check whether it is correct checksum or not. Okay. Forget about the details, because if you want to go to the details, it's not a big deal. You know the calculation, everything. At this moment, don't focus on that. But just remember that if checksum pattern is all ones, then your receiver can understand that checksum has been calculated and that receiver sender got all zeros. That's why he kept all ones. Now some students will have this question, sir, what if already case number 3, sir, checksum has been calculated at sender, but he got all ones. Then there is a confusion. How it is confusion, I will tell you. So whenever at receiver side, when that receiver UDP is checking for this checksum, so there are two cases. When all ones are arrived, then your UDP doesn't have clue whether this case or this case. Correct? So that's a problem. But it is impossible. Why? To have all ones, see the process. In the checksum calculation, we finally did ones complementation, right? Bitwise complementation, recall. So to have all ones, before that, the summation should give zeros. Okay. You don't understand it clearly here because you might have problem with checksum calculation. Please go to checksum calculation, then only you can understand. In checksum calculation, we added all these 16-bit binary patterns. Of course, we did through hexadecimal pattern, but both are same, not a problem. So you took all that 16 bits and you added. Then if you get all zeros, then only that that complementation will give you ones. You are getting all ones means before that addition should be all zeros. Correct? If you get all zeros, that means what? Everything. That means all that 16-bit patterns are zeros. Otherwise, it is impossible. At least, sir, we have other chance, sir. I have binary patterns like 10, 10, 0, 101, so that I got 0, 0 when I add them. So some carry I got, but I discarded it. But remaining thing all zeros. That is impossible. We are going to take the carry, right? And we add here. When you add if there is a carry, we will be adding so that your sum definitely will be non-zero. You never get non-zero, remember it. Okay, sorry, you never get 0. So to get 0, I just give rough idea. To get 0, first of all, the summation, there are two parts, summation followed by complementation. The summation part should give all zeros, then only complementation part makes all ones. But to get all zeros, everything should be 0. That means all that 16-bit patterns are zeros. But impossible, because we have IP addresses. They cannot be all zeros. Okay, that is one thing. Second one, we are using protocol. Protocol is, so here protocol value is UDP protocol's value is not 0. That means I can say there is at least one field which is non-zero in this one, in the checksum calculation. That's why we never get checksum calculation as all ones. That is a trick. So this case is eliminated. Finally, only two cases. All zeros, that means we intentionally kept. All ones, the calculation of checksum was done, but we got all zeros. Okay, all zeros. Where all zeros? Not here. In the overall process, all zeros is possible. because at the end we are doing bitwise complementation. After that you got all zeros, means before that it was all ones, the summation was actually all ones. Okay, so it is possible. Then we can differentiate two cases. This is about checksum. Finally, in the high level you understand, try to understand, it's not a big deal. At least you should understand that. So sometimes we calculate checksum, sometimes we don't calculate checksum. Okay, so this is about checksum process.